Hey there, fourth grade. Spend today on comparing decimals. And remember, whenever we use the word comparing in math, we usually mean are they greater, less than, or equal in value to each other, not compare like language arts. So, please make this your title. Once you're done, close it up till we get to the we do's. That's when you're going to write. And just concentrate and do your best with me until we get there. Pardon. So when we have compared two numbers in the past, like 309 and 317, the two ways we learned how to do that were with place value. So one is we kind of, looked at the place of each number until we found a difference, starting with the biggest place. So we looked at the hundreds first, and they were equal. And then we looked at the tens next, and 317 had more tens, and this had none. And so we know this number was the greater one. This one had more tens, and so it didn't matter what happened in the one, so we would say that that was greater. Didn't matter this had 9 ones because it can't have enough ones to possibly make a 10, and this has 10. The other way we would have done it, I'm just going to do this super fast, is we could look at a number line and kind of go by hundreds. And if we put them both on the number line, 309 would come before 317. Oops, 300. 309 would be like there, and 317 would be a little after it. And on a number line, whatever's to the left, farther to the left is less, farther to the right is more. And so we could tell that way too that 309 is less than 317. So we're going to go for the same skill today, but with decimals. So let me start with an easy one. Ryan lives 1 41 hundredths miles from school and 1 19 hundredths miles from the park. Which is closer? So let me give you 3 ways to think about this. You may already just be able to do this one easily, but let me talk you through 3 strategies so when we get to tougher ones, you have one that you can rely on. So same one. First thing I can do is look at place value. I can kind of line the 2 numbers up, and I can look one place at a time, starting from the greatest, and see which one's bigger. So here, in the ones place, they match, so I can't use that. And then here, when I get to the tenths place, this one has 4 tenths, this one has 1 tenth, and so whichever one has more tenths is going to be the greater number. So one way I can tell is just with the place value, the same way we did whole numbers. I can tell that 1 41 hundredths is greater than 1 19 hundredths. So that's with place value. Can also try with a number line. If I were to draw this number line from, let's see, they're both more than 1, but both less than 2. So I'll make my number line go from 1 to 2. 1 tenth, 2 tenths, 3 tenths, 4 tenths, 5 tenths, 6 tenths, 7 tenths, 8 tenths. Did a bad job on this number line. It's kind of spaced out. 9 tenths. And I would look and put them both on the number line. And remember, numbers to the left are going to be less. Numbers to the right are going to be greater. So 1 41 hundredths, I would go 1 4 tenths. And 1 4 tenths plus 1 hundredth, it would be right there. And 1 19 hundredths would be 1 1 tenth. And then 9 more hundredths. Would be right there. And I can easily tell that 1 19 hundredths is to the left, and 1 and 41 hundredths is to the right. So I know that this one must be the greater value. The one to the right is the greater value. And the other way, this is more of just to think about it. This may work for you, it may not. I like to think about like money or coins. You know, if I were to think of these instead of being distances as being money, sometimes my brain just sees that automatically. You know, I can just probably look at these and tell which one's greater. Like you may just be able to look at that and be like, oh, duh, I'd rather have $1.41 than $1.19. You know, this is like $1, 4 dimes, and 1 penny. And this is like $1, 1 dime, and 9 pennies. And it doesn't really matter that like 9 pennies, you know, don't let the 9 throw you off. 9 pennies, while that's the biggest number, the biggest digit in either of these, it doesn't really matter because the dimes here are worth so much more. You know, these match, but 4 dimes is going to be more than 1 dime no matter how many, unless you have like 50 pennies. And so sometimes just thinking about money is another way that you can do it without worrying about it. Okay? Let me do one more where it's not quite as simple to tell. Sometimes it can get confusing in a problem like this. So it says runner number 1 in the 100-meter dash ran in 10 and 3/10 seconds. And runner number 2 ran in 10 and 9/100 seconds. Who ran faster? All right. So I'm going to use the same strategies here, but what's tricky is when there's only one decimal in one of the numbers, and we just have tenths, I've warned you, that sometimes gets tricky because I look at this 3, I look at the 9. There's no other 0 here. You know, is that the same as this or this? Or what do I do? And so these can get a little tricky. So if I want to use the place value strategy, I just line them up, but I got to line up the place values, right? 10 and 3/10. And this one, there's 1 10, no ones, no tenths, and, whoops, not another decimal, 9/100, right? So this one has more digits, but that doesn't necessarily mean it's a greater number. It's easy to look at this and say, oh, this has 4 digits, this has 3, this one must be greater. That's an easy mistake to make, that more digits means more, but it doesn't matter, because look, if we go place value by place value, they match in the tens, they match in the ones, but they do not match here. This is 3/10 versus no tenths, and same way, it doesn't matter that this has more digits, it matters here, that the first value where they don't line up is the tenths. And since this has more tenths than this, that is the greater number. So 10 and 3/10 is greater than 10 and 9/100. Now, easy to see done. Remember the question's who ran faster? And another easy mistake to make is be like, oh, well, that's the greater number, so that guy ran faster. But remember, in a race, you want to have less time. A smaller time is better in the race. So this person was actually faster, and this person was actually slower. So don't make that mistake either. In a race, you're looking for the smaller time. All right, number line, same 2 numbers. These are between 10 and 11 seconds, so I'll make my number line go from 10 to 11. 10 and 1/10, 10 and 2/10, 10 and 3/10. I'm going to pause so you don't have to watch me do that. And there you go. There's all my tenths between 10 and 11 seconds. And so if I want to put these on the number line, got to do some partitioning. So 10 and 3/10, actually no more partitioning there, right? There's 10 and 3/10. I don't have to partition any farther because it's just tenths. For my hundredths, I do. So I have 10, no tenths, and 9/100. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's right there. So that's 10 and 9/100. That's 10 and 3/10. And if I look at those, I can tell numbers to the right are greater, numbers to the left are less, and so I can tell that's less than that. Faster, slower. All right. Last thing I told you, think about money. Instead of whatever it is, if there's a decimal, money can help you. You know, I'm asking really here is $10 and 3 dimes greater or less than $10 and 9 pennies? Because if you look in the place value, the 9's in the hundredths place or the pennies place. This is $10, 3 dimes, and no pennies. This is $10 and 9 pennies, and it's, you know, this may or may not be something that's obvious in your head. To me, it's obvious that this is more money, and it is. I just don't want this to confuse you. You're like, oh, well, 9's greater than 3, so the one with the 9 has to be greater than the one with the 3. It doesn't. Those are the two easy mistakes to make when you look at a problem like this. Here are the two ways to mess this up. One is to say, well, 9 is greater than 3, so that has to be greater because it has a 9 in it. And it doesn't work that way because the 9, it matters what place the 9 is in. The other thing that's easy to mess up is to say this has 4 digits and this only has 3 digits. So the one with 3 digits has to be less, and that's not true either because, again, it matters what place they're in. That was true without decimals. You know, a 4-digit number was always going to be greater than a 3-digit number when we're in whole numbers because it has an extra thousands place. But once you add a decimal, it doesn't necessarily work that way. All right, open up your notebook and let's do one together. Let's do, I've had 2, we're only going to do 1. We're going to do this one. All right, another race. Runner number 1 ran the 400-meter dash in 53 6/10 seconds. Runner number 2 ran it in 53 9/100 seconds. Who won? All right, so your first strategy is place value. In place value, I'm going to line up all my places, 53 9/100 and 53 6/10. Now, don't be fooled. This number has fewer digits. That doesn't mean it's smaller. Don't be fooled there. Because when I look place by place, they match. They match. But when I get here, 6/10 is more than 0/10. So this is the greater number. So 53 6/10 is greater than 53 9/100. Now remember, this is a race. So it doesn't necessarily matter what's greater. I asked who won the race. So this is a faster time, and this is a slower time. So the lower time won, and the lower time was 53 seconds. All right, I'm going to pause and make my number line. So you don't have to sit there and watch me put all these tenths out there. It's going to go from, these are both more than 53 and less than 54. So if you want to make yours too and pause, I'm going to make it from 53 to 54 seconds. Ta-da! There's my number line. So let's see, 53 6/10. That's already on this number line. I don't have to do any more partitioning. 53 6/10 is there. And 53 9/100. I'm going to go to 53. No tenths, not even 1/10. And 900s, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's right there. 53, no tenths, 900s. And I can see that this is less and this is greater. So that is less than that. 6. All right. Last one, I'm short on time, so coins, I'm going to have to go fast here. If you want to think about that, I'm comparing $53 and 9 pennies to $53 and 6 dimes. Even though 9 is more than 6, dimes are worth way more than pennies, so this is the greater number. 53 and 6/10. I am out of time. Please go back and watch an example if you need to again. See you tomorrow. Bye.